think as a symbol for the university is very much an attempt to try and bring together or emphasise what it is that RMIT considers to be its strengths in terms of technology and design and its aspirations in those areas.
The university was looking at redeveloping a mace, and we took on board that project from both an architectural and an industrial design perspective.
So the project really became a collaboration between the different types of work that we do. So the work that I do is focused on algorithmic design, computational design, and we were looking at what is the relationship between what are effectively bottom-up processes of design and the way they relate to more direct formal modelling and manipulation of form. So I guess one of the key things about this project is it's supposed to bring together the leading work that's happening in design and also in technology at the school. So part of this technology is software side technology in terms of design process, and part of this has got to do with the technology involved in actually fabricating or making the mace.
One of the really interesting things that we were able to do with that algorithmic process was to look at how we actually optimize the structure of that algorithm. Because effectively the swirl patterns within the mace, some of them aren't able to be manufactured in the printer itself. So we're able to write some software that went in and actually looked at all of the geometry that wasn't buildable, and we could remove that geometry from the algorithm and then replace it with geometry that would allow us to build the structure of the mace in the titanium 3D printer.
The algorithm loosely fits into a category that's described as a behavioural algorithm, or in this case it's a multi-agent algorithm. This is an algorithm that we see a lot within natural systems. So it's the underlying algorithm that operates within flocks of birds, schools of fish, the way social insects interact. And it's an algorithm in which it looks at individual entities, and we describe them as agents, and the way those agents interact without any understanding of the overall flock or form or swarm, but simply through some very simple relationships to those that are immediately adjacent to them. And through all these thousands or millions of interactions, then some type of global behaviour emerges from that.
For us, it was a really great project to look at those traditional form creation processes and then how to bring in the computational work through the swarm algorithms and how the structure could be reinterpreted from a new paradigm in terms of additive manufacturing.
So the mace is printed in 4 parts. So it has these three primary joints, and this is limited by the size or the bed size of the 3D printer. The 3D printer is laying down layers of titanium, which are very, very thin, and then it's welding those together effectively with a laser. In the end, you end up having a volume of titanium powder, some of which is fused together, welded together, and that becomes the object. But suddenly when you're printing something at this small scale, the technology completely changes. And so to realise that the best person to fix the different parts together is a jewellery designer, somebody who's able to actually weld titanium under a microscope at incredibly fine scales.
Putting together the mace, we were hand linishing and hand polishing components and checking fit and bringing the mace together to really, in effect, to have a gap of the thickness of someone's hair. The way that the current mace is formed, it really shows how RMIT can work together to collaborate and how those strengths work between design, engineering and gold and silversmithing in this case to bring the mace to fruition.